Hello, me again for more math. We are on lesson 16.6. We are checking workbook page 272. So get what you need, ready? We are doing, wait for it, word problems. All right, word problems, not as hard as we think. We just gotta go step by step, take a deep breath, and work one step at a time. Step one, read the problem. Just read it. Read it the first time. Don't worry about doing anything. Just read it. Try to picture it up here. Number two, or not number two, with read, the second time you read it, really try to understand it. So you read it the first time. The second time you read it, really try to get a good picture of what's going on in your head. Read and understand. Number two, represent the situation. That's drawing some sort of diagram, picture. Maybe it's just pulling the numbers out of the words. In word problems, it's almost like we're going from words and we're taking it out and we got to go into the math world. So take those things out and write them down in mathematical ways. So you see the numbers instead of seeing the words, or you draw a picture. And remember, it doesn't have to be this beautiful picture, Gabby Zidek. You can just bring it out and draw stick figures and little circles to represent, trees. They don't have to be this amazing pictures, okay? We're worried about the math of it, not the art of it. Although I do like to see your pictures, Gabby. Then number three, we're going to solve and check. And if you look here, I have a little arrow that goes back and forth because sometimes we solve it or we think we solve it and we check it. And if you really check it to see if it makes sense and it doesn't, you got to go back and solve it again. You can't just solve it and hope for the best. Solve it, check to make sure it makes sense. If it doesn't, go back to solve, check again. If it doesn't make sense again, you got to go back. Go back until you find the answer. We can't stop. And then the last one, write your answer in and make sure that you've labeled it. Label that answer, because in math and science, we need to be very specific, very black and white. It's not just 3, it might be 3 centimeters or 3 apples or 3 iced coffees. All right, let's start. We are on number 5 on page 272. The reason that we're on number 5 is because it's actually an extension of the first, this one that we did in the last video, page 271, but we already checked numbers 1 through 4. So we're going back to number 5, okay? All right, here we go. I'm gonna read first. Jamal earns $15 raking leaves on Monday. He earns $8 each day after that. How much does Jamal earn altogether by Saturday? Complete the table to help you find your answer. If the table wasn't there, I would have pulled those numbers out and made my own table, but they give us a little bit of a hint here. So I already have a representation of the situation right there. So let's read it again. And this time we're going to start to pull out the numbers. So Jamal earns $15 raking leaves on Monday. So on Monday, he earns $15. So I'm making their table, I'm just making it a little bit differently for time's sake. On Tuesday, he earns $8 each day after that. So he earns $15 on Monday. I'm not gonna write that he earns $8 on Tuesday. What I'm gonna do is add the 8 to the 15 already, so I know how much he makes on Monday and Tuesday together. Because my question says, how much does Jamal earn all together by Saturday? So if I were doing this problem, let me put this up here to the board here. If I was doing this problem, highlighting is a great strategy to doing these problems. So Jamal earns $15 raking leaves. So I would highlight $15. He earns $8 each day after that. $8 each day after that. And then real important is, how much does Jamal make? And I'm gonna actually highlight that in a different color because that's my question. How much does Jamal earn all together by Saturday? So it's not how much does he earn on Saturday, how much does he earn all together by Saturday? Did you like how the pink and the yellow made orange? I made a third highlighter color, and I only have 2 highlighters. All right, that was a shout out to Miss Meckling and primary and secondary colors. All right, here we go. So on Monday, he earns $15. On Tuesday, he earned $8 more. So we got to figure out 15 plus 8. So hopefully you all can do that in your head. If not, I can come down in my scrap paper and I can write 15 plus 8 on my scrap paper, and that's okay. So 15 plus 8, I come up here and I get $23. So on Tuesday, he earned $23 altogether so far. He didn't earn $23 on Tuesday. He earned $23 in addition to putting Monday and Tuesday's earnings together. Okay, on Wednesday, he earned another $8. So it's almost like I'm adding 8. Let me get my other color markers here. So I'm adding 8 each time. So Tuesday, Tuesday he gets $8 more. So that would be 31. And then he earns $8 more. So that on Thursday, he has 39 altogether. On Friday, he gets $8 more from Thursday, and that will be $47 altogether. And now the big kicker, on Saturday, he got another $8, and that will be, drum roll, $55. So Jamal, your sentence for number 1 should say, Jamal will earn $55 by Saturday. Okay, pause, check your answer, mark it right or wrong, and let's go on to number 6. I'm going to read as I erase. After the first hour of the carnival, 325 tickets had been sold. After 2 hours, 650 tickets had been sold. After 3 hours, 975 tickets had been sold. If the pattern continues, how many tickets will have been sold after 5 hours? Explain. So now this time they didn't make the chart for us. We've got to make a chart. But hopefully you noticed that this problem was very similar to the problem before. So we're going to make another chart. Let's read it a second time. And as we read it that second time, we're going to understand the situation and try to represent it. Okay, so here we are. I'm going to get out of the picture and zoom you more in on my whiteboard here. All right, after the first hour of the carnival, 300 tickets had been sold. So in hour 1, can you see that? Yeah. First hour, 325 tickets had been sold. And I'm going to abbreviate that TIX, tickets. First hour, 325 tickets. Then it goes on to say, after 2 hours, so after the second hour, 650 tickets had been sold. After 3 hours, 975 tickets had been sold. And then they stop. And it says, if the pattern continues, how many tickets will have been sold after 5 hours? So I need to fill in after the 4th hour, and then I need to fill in after the 5th hour. And after the 5th hour, this will be my answer. How many tickets are sold? Now here's the key words here. It says, if the pattern continues. Well, how many people said, well, what's the pattern, Mrs. Hotsfeld? So you have to look and you have to find the pattern. So you have to look and see what happened to 325 to get to 650. and what happened to 650 to get to 975. So in order to do that, we've got to subtract. So we are going to subtract 650 minus 325. And in order to get from 325 to 650, we had to add 325 tickets. So to go from 325 to 650 was plus 325. Now you might say to yourself, oh, that's the pattern. But remember, it's not a pattern unless it happens a second and at least a second time, preferably a third time. So here's 650. What happens if I add 325 to 650? Will I get 975? If I do, then I have a pretty good idea that that's my pattern. So let's look, 650, and I'm gonna add 325. You could also have started with 975 and subtracted 650 to see if you get the 325 pattern. Either way would have worked. So let's start with the 650 tickets first, add 325 and see if we get 975. And we do. So that's a good pattern. So I added 325 to 650. Some of you might have said, well, I took 650 and subtracted 325, got my 325 as my first addition of tickets, 975 minus 650, also 325. So the difference between these two numbers is 325. The difference between these two numbers is 325. So that's a good pattern. So I'm using my pattern of 325 to see how many tickets got sold after the 4th hour. So I'm gonna actually use this whiteboard here, 975, and I'm gonna add my 325. Can you see that? There we go. 5 plus 5 is 10, 7 plus 1 is 8, plus 2 is another 10, 10, 13. So we have 1,300 tickets. So that's gonna go after the 4th hour, I sold 1,300 tickets all together. I'm gonna bring that 1,300 up here, add my 325 ticket pattern, add that up, and I have 1,625 tickets. So 1,625 tickets all together, sold after 5 hours at the carnival. Good? All right, pause it here if you need to. Make the table, check it, try to understand it, try to put it in your brain how we found the pattern. We had these two numbers already, so I subtracted those two numbers to find the difference, to find the pattern. And then I took that 325 and added it to the 650 to see if we got 975 to continue the pattern and see if it was a good one, and it was. Then I kept adding 325 until I got to my 1,625 tickets. Good? All right, moving on. We've got, ooh, I like this problem. Okay, this is a working backward problem. All right, cuties, on to number 7. Let's read it. Bryson has $325 in his savings account after making 2 deposits of $35 each and 1 withdrawal of $41 each. How much was in the account before the 2 deposits and 1 withdrawal? Yikes. How many of you went to Mom and said, oh, Mom, I have no idea what this question's asking me? I can understand that because there are a couple words in there that you might not have recognized or known. First is an account. An account is something that you hold at a bank, and you can give money to the bank to hold for you, or you can take money back out. So that's called an account. So you hold an account at a bank. If you want to take money to the bank and give it to them and put it into your account, add it to your account, we call that a deposit. So when we deposit something into the bank, we are adding it to our account. So a deposit is adding into the account. A withdrawal means you're going to the bank and you're taking money out. I don't know, maybe you need some iced coffee at Dunkin' Donuts and you say, hey, I need some money from my account, so I gotta go to the bank and I gotta withdraw it. Can you tell I'm missing my iced coffees? So we've got account, we've got deposit, and we've got withdrawal, okay? Deposit means to add, withdrawal means to take out. So now let's look back at our problem. Gotta drink water now. Let's go back to our problem and represent the situation. Bryson has $325 in his savings account after making the deposits and the withdrawal. So he ends up with $325. So I'm going to put that at the end. Okay. Moving on, it says after making 2 deposits of $35 each and 1 withdrawal of $41. How much was in the account before the 2 deposits and 1 withdrawal? So I need to figure out what was in the beginning. I don't know. So what I'm going to do is I'm going to work backward eventually to come up with this answer. But first, I'm going to find out what happened forward. So I start off with, I don't know how much. What did Bryson do with this money? Well, it says that he made 2 deposits of $35 each. So he had some money in the bank and he made a deposit of $35 and another deposit of $35. So he started with, I don't know what, he added 35 and he added another 35. And then it says he made a withdrawal, so he took money out of $41. That's a lot of iced coffees. And then he ended up with $325. Okay, so now I know what he did, what he ended up with. I got to find out what happened in the beginning. What did he start with? So I got to work backwards. So let's take a look at an easier problem and see if you can figure out what we have to do to work backwards. We talked about this earlier in the year. If I don't know how much I have, but I know that I added $2 and I ended up with $6, how much did I start with? Remember those? The answer is 4. So I started out with $4. That's something that you can see in that, oh yeah, of course I started out with $4 because if I add 2, I get 6. So you can see that because it's easier problems, easier numbers to work with. Remember that word that we talked about at the beginning of the year called inverse operations, the opposite operation. If we have an unknown, we have to do the inverse operation to find the answer. So if I have something plus 2 equals 6, I do the opposite operation with 6 and 2 to get 4. So to work backward, I started with the 6, I subtracted the 2, and I got my 4. We're going to apply this same idea up here. So to work backward, we're going to use the inverse operations, which means the opposite operations. So let's start that. So before I even do any computation, any adding or subtracting, I'm just going to write it all out. So I'm going to start with my 325 and I'm going to work backward and I'm going to say, okay, this day he withdrew $41. So before he withdrew $41, he had that $41 in his account. So I'm going to add it back in. This day, and let me do it like this so you can see it a little bit better. Let's bring some colors in. So if he subtracted $41 to get the 325, I'm going to add the $41 back in to find out what I started with. Up here, he added $35. So down here, I'm doing the inverse operation, the opposite. So I'm going to subtract $35. Same thing here. He added $35. I'm going to subtract $35. And if I do that, I will come up with the answer that I need to match what he began with, okay? So I'm gonna take my other whiteboard because I'm running out of room. Ready? 325 plus 41. So I'm doing this problem right here. 325 plus 41. 5 plus 1, 4 plus 2, 3 plus 0, 366. So 366 was right there. I'm going to take that 366 and I'm going to subtract 35. Got what I'm doing? 6 minus 5 is 1, 6 minus 3 is 3, and 3 minus 0 is 3. So here's 331. I'm going to subtract again. Subtracting 35. I'm going to borrow. 11 minus 5 is 6. Borrow again. Regroup. 12 minus 3 is 9. Bring down the 2. 2 minus 0 is 2. So $296 is what I think we started out with. So I think he had $296 in the bank before he added the 35s and subtracted the 41. But now I gotta check. I can't just hope my answer's right. So I'm gonna go back and I'm gonna do the problem from the beginning to the end to see if I got it right. So in this little box, I'm starting with what I think is $296. So I'm gonna add the $35 deposit. So I had $296 sitting in the bank, Bryson did, and he went to the bank and he deposited $35. 9, 10, 13, and I got $331 in the bank now. Then the next day he went back to the bank and he deposited another $35. And he had $366 in the bank. Then he decided to go to the bank and take out or withdraw $41. And now he has $325 in the bank. Okay, so I had to work backward and then I checked it, put my answer in, that $296, and I worked forward again with the problem to make sure that I ended up with the $325 that the problem tells me that Bryson has in the bank now. Okay? So he started with $296, deposited $35, withdrew $41, and got $325. Whew! All right, number 8. The difference of two numbers is 15. The product of the numbers is 700. What are the two numbers? Love these problems. Once again, boys and girls, these are not problems that are going to come like that in your head. You got to work them out and write them out. And sometimes we have to guess a little bit and check. And that's what this problem is going to entail. I don't have these two numbers in my head automatically. When I went to figure this problem out, I guessed. And then I checked. And then I made a better guess. And I checked again. So it says the difference of two numbers is 15. So you got to know what the word difference means. The difference is the answer to a subtraction problem. Difference. The difference is the answer to a subtraction problem. So my problem says the difference of two numbers is 15. So I'm going to represent the situation. And I'm going to say this number minus this number equals 15. The difference of two numbers is 15. Now I'm going to show you this real quick because you guys are big and you're really good at math and I think you're ready for this. Don't tell the 6th graders. But we can represent these boxes with numbers. And we call them variables. We've talked about that before in class. So actually, I'm going to keep those boxes up there so that you can see. But when you're big, you write it like this. X minus Y equals 15. And these two numbers, these two letters, represent some numbers that we don't know yet. Just like the boxes represent numbers that we just don't know. We don't know what they are, but we do know that when we subtract them, we get 15, okay? And then it says the product of the numbers is 700. So the product is the answer to, I hope you just said multiplication. If you didn't, I'll never know. Multiplication. Product is the answer to a multiplication problem. So I know up here that these same two numbers, if I multiply them together, I get 700. So if I represent that with letters, I have to use the same letters because they're the same numbers. So these two numbers that we don't know, if I multiply them together, and now take a look at that, XX. So I'm going to show you another trick we use in 6th grade. And we use a dot as a multiplication symbol so you don't get it mixed up with the letters that you use to represent numbers that you don't know. So x times y equals 700. Okay, if this confuses you, put it out of your mind and work with the boxes. But I know some of you have seen this before. We've done it before in class, and you can kind of get a picture of that. Okay, so this is what I know. Two numbers subtracted will equal 15. The same two numbers multiplied will equal 700. So this is how I started. And I said, there are only so many numbers I can subtract to get to 15 that you can also multiply and get 700. So what I started with was immediately the numbers 20 and 5 came in my head. I don't know why, and you're gonna see that they were too low anyway, but I'm gonna show you the guess and check method. So I first, like I said, 20 and 5 just popped in my head. So 20 minus 5 does equal 15. That one made sense. But when I came over here to multiply them, 20 times 5 equals 100. So that 100 was too low. So I know that these two numbers are too low for my answers, okay? So I'm going to erase those, and 20 and 5 did not work, too low. So then I thought, I need to go higher than 20 and 5. So I'm gonna go 30 and something. So I made 20, 30, and now I have to figure out the other number that goes here that when I subtract that number will give me 15. So in order to do that, I have to do subtraction. So 30 minus this number here equals 15. So if I subtract that 15 from 30, I'm gonna get this answer. 10 minus 5 is 5, 2 minus 1 is 1, and I get that 15. So the 15 actually goes in here. So 30 minus 15 equals 15. So now I have to see if 30 times 15 is going to equal 700, or if it's going to even be close. So I'm going to multiply, oops, not 300, I'm going to multiply 30 right here. I'm going to multiply 30 times 15. 5 times 0, 5 times 3 is 15. I'm multiplying by the 1 now, so I got to put my magic 0 because it's in the tens place, so my answer has to go in the tens place. Remember, 1 times 0 is 0, 1 times 3 is 3. I add those numbers, 0, 5, 4. 450. Not close to 700. Also too low. So 30 and 15, I wrote little notes here to myself, too low. That product was 450. Up here I got 100 for 20 and 5. It was too low because it was only 100. 30 and 15, the product of that one was also too low. It was only 450. But look how much I did jump. So don't start going up real high. We only need a little bit more in this factor in these two factors to get a higher number here. So I'm looking for two factors that will give me 700. So these two factors gave me 450. I don't need to go too much higher to get 700. So I'm not going to go to 40. I'm going to go to 35. And I'm going to say 35 minus something equals 15. So I have 35. Remember the whole in parts box that we do sometimes in class? I have 35. I know I'm going to have 15 left. So what's the other part? To find out the other part, I have to subtract this 15 to find out what this is. Okay, so I'm going to come over here and I'm going to find 35 minus 15 is 5 minus 5 is 0. 3 minus 1 is 2. Some of you can figure that kind of stuff out in your head. Others of you need to do that work, and that's fine. Okay, so 35 minus 20 equals 15. So my next two numbers I'm going to try are 35 and 20. So I know it works over here. Now I got to see over here. So let's multiply 35 and 20. Ready? 35 times 20. 0 times 5 is 0. 0 times, here's our trick of the zeros. Remember, when we have 0 in the ones column, I can put the 0 in the ones column here and be finished. Okay? And then go on to multiply the 2 times 5. That acts like as my magic 0. 2 times 5 is 10. 2 times 3 is 6 plus the 1, is 700, which was what I was looking for. Let me just go backwards and remind you of that trick of the zeros. Remember, some of you sometimes in class will say 0 times 5 is 0, 0 times 3 is 0. Well, of course they're both going to be 0 because I'm multiplying by 0. And then I come down here and I put my magic 0 to hold my place to multiply by the 2 in the tens column. 2 times 5 is 10. 2 times 3 is 6 plus the 1 is 7. And then I can add those numbers up. But you see, this step here is unnecessary. I actually don't need to do it. I can just put my magic 0 here because anything times 0 is going to be 0. So I can hold that place with my 0 and then come over here and multiply by the number in the tens column, and my answer has to go in the tens column. So 2 times 5 was 10, 2 times 3 is 6, plus the 1 is 7. So I end up with the same answer. This is not wrong. I don't care if you do it, but it is an extra step and more writing that you don't have to do. So if you get this shortcut, use it. If you don't, come back here. Either way, we found our two numbers. 35 times 20 equals 700. That made this one true and this one true. So if you were doing big 6th grade math, in 4th grade, we would write those numbers in the box and say our two numbers are 35 and 20. If you were doing big 6th grade math, you would say x equals 35, y equals 20. So I need an x. The x here needs to be replaced with 35. The y here needs to be replaced with 20. Same over here. The x would be 35. The y would be 20. If you don't get that part, no worries. If you do, awesome. Whew, these word problems. All right, on to number 9. How could you use perpendicular lines to draw two parallel lines? We actually talked a little bit about this in our other problems with those maps. Remember, with the perpendicular and parallel lines? So it says, how could you use perpendicular lines to draw two parallel lines? Well, if I have perpendicular line That means two lines that intersect to form four right angles. So there's my right angle sign. I know if this is a right angle, this one's also a right angle. So I don't have to write the square in all of the boxes. I only have to do it in one. So there's my 90-degree angles, and it says, how can you use those perpendicular lines to draw two parallel lines? Well, if I know that this line here forms a perpendicular line to this line, then all I have to do is draw another line perpendicular to this one, and maybe we should name them. Let's name this one A, B. So AB is perpendicular to CD. So if I draw another line perpendicular to AB, I'll draw that one in green. This one's also perpendicular. If these two lines are both perpendicular to AB, it makes these two lines parallel. Okay? All right, those are your word problems for page 272. Now, if you have more questions on any of them, email me, and I will either just email just to you or send you a little video that explains a little bit, or maybe I'll even do like a Google chat and get on there with you and explain it to you one-on-one. If we're all good, then we're going to move on to a review in math, and I'll explain that a little bit later, a review for chapter 16, and then we'll move on again, okay? Good job on your word problems. I'm proud of you for trying them and to work hard. I'm gonna ask again that you take a picture of those word problems and send them to me so I can see how you did, okay? All right, have a great day, 4th grade. I miss you, I love you. See ya.